Hey, you guys, I wanted to log in and go over this slide that we did in class and what I asked you to do the second part. So the second part of this slide, let's put in some dimensions here. Because this long skinny rectangle has an area of y, and we know that one of the sides is 1. This side of the rectangle is 1. 1 times y will give us an area of y. Now, we only have y there. Y could be anything. That's why we have a variable. What if that length right there wasn't y? What if it was 10? Okay, then instead of being y, the area would be 1 times 10, and it would be 10. What if it was 25, right? Then the area would be 25 because it would be 1 times 25. But it's y, which means that this side of this rectangle must be y, and y times 1 is y. So the area is y, and we know the length from here to here is y. This is a square. This is our y squared algebra tile. So I also know the length from here to here is y because it's a square and all of the sides have the same length. Now, let's go back. Let's pretend that y, instead of y, it was 10, right? Then the area of this square would be 10 squared, 10 times 10, length times width, or we could just write that as 10 squared, right? So if both of the sides were 10 for that square, our area would be 10 squared. But it's not 10, it's just y. The number is y, and that's okay. That is okay. That just means instead of our area being 10 times 10, our area is y times y, which is equal to y squared. So our area is y squared. Okay. Then this is x squared, which means this side and this side are both x. This is the same size. This is also x squared. This is x on this side, x over here, x here, x here. This is y, y, 1, 1, 1, 1. Now here's a couple of tricky parts. Here is a couple of tricky parts. We need to know, we need to be able to figure out the distance from here to here, and also from here to here, because we don't know what they are. We know both distances are part of y, right? So let's go back to pretending that instead of y, that this was 10. If, instead of y, if this is 10 all the way across, okay, and I go 2, what's left over? If it was 10 all the way across and I know this is 2, what's left over? Well, then this would have to be 8 because 8 plus 2 would be the full 10. The way we got that 8 mathematically was 10 minus those 2 blocks we already knew were there, which was 8. But again, it's not 10, it's just y. So instead of 10 minus 2 giving us 8, we have y minus 2. And we just keep it just like that. From there to there, that pink is y minus 2. And we just leave it like that. It's actually less work than dealing with numbers. So same thing when we're looking at this side. From here to here, this whole distance is y, but we need to subtract out just from here to here, which is x, to get what's left over. So from here to here, we're just going to call y minus x. And I'm going to erase everything that might be confusing us so far because I want to find the perimeter. So I just want to know those numbers on the outside that I need to add up. Okay, all those green things on the outside are what I'm adding up. So first of all, you can combine like terms. So all of these ones, I'm going to highlight in yellow because they are all like terms, right? And then all of the X's, I'm going to, oh, I can't highlight in green, they'll disappear. I'll highlight in blue. X, 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 kind of covers it up, but hopefully we remember that the blue is X's. And actually this X is blue too. And then let's do our Y's. I don't know if I'm going to get a good, I'm not going to be able to. Let's just circle them. Y, 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 Y. Oops, I forgot a 1. Do you see the 1 I forgot? I forgot this 1. And actually, I'm going to highlight this -2 because it is also just a number in yellow. So now to find the perimeter, we are just going to do add up all of the yellows first. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, but we've got to subtract these 2. We have a -2 there. So everything in yellow, if we combine it, becomes just 4. Now let's add up all the X's. We have 1, 2, 3, 4, 5 X's, but we need to subtract this X here, so we really just have 4 X's. And now the Y's. We have 1 Y here, 1 Y here, and then a Y here and a Y here. So actually 4 Y's. So that is the perimeter. Pause this video, type it in to your slide, and I'm going to erase everything so we can start over with the area. I need a bigger eraser, or I guess I could have just cleared all. That's fine. I like this green color on here. I'm going to keep using it. Okay, it's like, what's her name, Skeeter from here, keeping with the Harry Potter scheme. So we know this area was y squared. We talked about that already. We know this one is x squared. And these are just 1 because each side is 1, 1 times 1. To find the area as a sum, we're just going to add all the middles up. So let's start with our x squareds. We have 1x squared, 2x squared. So I'm going to start with 2x squares. So I'm just literally counting how many squares that have side x there are. There's 2x squares plus, we only have 1 of the y squares, plus we only have 1 of the y rectangles, the y by 1, so we just call that y, plus 2. Okay, take a moment. Pause, type that into your slide. And if you didn't get this in class, let's quickly go over the one above. If you did, you can stop listening. Okay, so let's just do the area first because it's the easiest. Each of these is just 1 because each side is 1. This square here, both sides are x, which means the area is an x square. If you have a square and every side is x, it's an x square, right? And each of these rectangles, one side is x and one side is 1, so these are all just x. So the area, if I add up all of the x squares I have, or if I count all of the x squares, I just have 1, so I have 1x squared. But you don't need that 1. How many of just the x tiles do I have? I have 3 of the x rectangle tiles, and I just have 3 1s, so that's the area. And I don't need this 1 here, but you can put it there if you want. Both ways are correct. Now the perimeter, which is a little bit harder, is I'm going to erase all the areas because we don't need them. We just need the outsides for the perimeter. So we have from here to here is x, from here to here is 1, another 1, another 1, an x, because that's the distance, that's how long that is. Then a 1, a 1, a 1, another x, a 1, a 1, a 1, a 1, a 1, a 1. This one is tricky. The whole side length is x, and then from here to here is 2. So what's left over is x minus 2. Okay, so let's start off counting our x's. We have 1x, 2, 3, 4. So I count 4 x's. I'm going to erase that, it's getting in my way. Oh, that's area. I meant perimeter. So the perimeter is 4 x's plus, and then how many 1s? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But then I have to take away 2. So I have 12 take away 2. So I actually just have 10. Let me write the area again, which was x squared plus 3x plus 3. Okay. All right. Thank you, everybody, for class today. I can't wait to see your beautiful faces or icons tomorrow. Please send me a reminder or an email if you have any more questions.